We finished off that quiz last week, so today we're going to look at these functions and how they're actually applied to the triangle. But before I do that, I want to actually look at the behavior of these functions. So we'll take a quick look back at our unit circle. And now remember, sine is the y-coordinate of that point on the circle, and cosine is the x-coordinate of that point on the circle. If we have the angle here of 20 degrees, which is a fairly small angle, it traces out, or it identifies that point on the circle. So the sine of that angle is that length there. The cosine is this length here. So it comes out to literally be the y-coordinate and the x-coordinate of that point, because this is a unit circle. As that angle gets smaller, so let's say it goes from 20 degrees down to about 2 degrees here, what happens to the sine, the value of the sine? Does it get bigger or smaller? It gets smaller. In fact, it gets close to nothing, right? 0. If that angle were 0, the sine would be 0. As that angle gets smaller, what happens to cosine? It gets bigger up to what value would it get to at 0 degrees? The radius of the circle is 1. Right? So unit circle has a radius of 1. So at 0 degrees, this length here for cosine is just the radius of the circle. It's 1. As that angle got larger, it went up to here, what happens to the sine? Sine gets bigger. The cosine gets smaller. In fact, as that angle gets close to 90 degrees, the sine gets close to being what? 1. In fact, at 90 degrees, the sine would equal 1. I can actually write in sine of 90 degrees equals 1 there. What would the cosine be at 90 degrees? 0. If I keep going over here, as we pass 90 degrees, as we keep going, of course, sine now starts to get smaller. Cosine becomes negative. Good. As we approach 180 degrees here, sine becomes close to what again? 0. So sine of 180 degrees actually is 0. Cosine of 180 degrees is negative 1. As we keep going, here at 270, sine of 270 degrees is what? It's negative 1. Cosine of 270? 0. And of course, here at 360 or 0, we said sine is 0 and cosine is 1. So up here, both sine and cosine are positive. Over here, sine is positive, cosine is negative. Over here, sine is negative, cosine is negative. Over here, sine is negative, cosine is positive. So because of that relationship and the relationship that these have with other trig functions, for example, the secant of an angle is the reciprocal of the cosine. If I label these quadrants 1, 2, 3, and 4, just like on a graph, in which quadrant is secant positive? Well, if secant is positive, would cosine have to be positive or negative? Careful. 1 divided by a negative number would still be negative, right? A positive divided by another positive is positive. So for secant to be positive, cosine has to be positive. So secant will be positive wherever cosine is positive, in the first and the fourth quadrants. Cosecant is the reciprocal of sine. So it's going to be positive wherever sine is positive. So sine is positive in the first and second quadrants. So cosecant would be positive there. Cotangent is the reciprocal of tangent. It'll be positive where tangent is positive. The question is, where is tangent positive? Well, tangent is equal to the opposite side over the adjacent side. Sine is equal to the opposite side over the hypotenuse. Cosine is equal to adjacent side over the hypotenuse. So if I do sine divided by cosine, what I am doing is opposite over hypotenuse divided by adjacent over hypotenuse. When I divide two fractions, which is what I'm doing here, I multiply by the reciprocal. So the top number, opposite over hypotenuse, is just going to stay as it is, that top fraction. I'm going to multiply by the reciprocal of this one. Will become hypotenuse over adjacent, and you see the hypotenuse cancels out, and I'm left with what? Opposite over adjacent. Well, why did I go through all that effort? Because tangent is opposite over adjacent. Therefore, tangent can be found by doing the sine of an angle divided by the cosine of an angle. So for tangent to be positive, sine and cosine can be positive. Tangent will be positive there. We're both sine and cosine will be positive. Is there any other place where the tangent would be positive? Yeah, where both of them are negative, because a negative divided by a negative is positive. So tangent is positive in the first and the third quadrants. Okay, enough of that. Let's actually start looking at some angles here. Let's say cosine of 70 or cosine of 60. Which one is larger? So let's look at this as we go from 60 degrees here up to 70 degrees. Cosine is this dimension. As the angle gets bigger, cosine gets smaller, right? So the cosine of 60 will be the larger one. You don't need to punch that in our calculator to figure that one out. The sine of 10 degrees or the sine of 20 degrees? Well, sine here, as we go from 10 to 20, sine gets larger as the angle gets larger. So the bigger angle is larger for the sine. So that's not so bad. As long as we're between 0 and 90, the smaller angle has the bigger cosine, the bigger angle has the bigger sine. So let's compare sine of 30 degrees, cosine of 50 degrees. Now you might be wondering, how on earth can I compare two different functions? We're going to leave the sine of 30 degrees as sine of 30 degrees. But we're going to change the cosine of 50 degrees into the sine of what angle? Remember, cosine equals the sine of the complement. So what's the complement of 50? 40. 90 minus 50 is 40. So which is bigger, sine of 30 or sine of 40? Sine gets bigger as the angle gets bigger. So sine of 40. So cosine 50 is bigger than sine of 30. Which is bigger? Sine of 70 degrees or cosine of 15 degrees? Well, again, I'll keep the sine of 70. What am I going to change the cosine of 15 into? Sine of 75. Good. 90 minus 15 is 75. So cosine of 15 is equal to the sine of 75. Which one's going to be bigger, 70 or 75 for sine? Sine, the bigger angle, has the bigger sine. Make sense? Okay. It's just a matter of, I don't care if you get real exact with that, but just being able to reason out, okay, because that cofunction relationship, cosine being the sine of the complement, being able to reason out the size of those angles, the size of those functions. So, if I give you a right triangle, and I tell you that one of these angles is 31 degrees, and I tell you that one of the sides, let's say this one here, is 14 inches. Every triangle has 6 pieces. It has 3 sides and 3 angles. If I know 3 out of those 6 pieces, usually I can find the other 3. The only exception is if all 3 of the things I know are angles, I can't do anything with that. Because the sides could be any length. Just knowing the angles just makes the ratio of the sides the same, but we don't know exactly what length they are. So we have to know at least one of the sides. But if I know any 3 of those 6 and at least one of them is a side, I can find the other 3 pieces. Here, I have 3 things. I have 2 angles, the 31 and the 90 degrees here, the right angle. And I have one of the sides. So I'm going to label this A, B, and C. This is side A, B, and C. So I want to find sides A and C and angle A. Now looking at this, one of them I can find really quickly and easy. Can anybody tell me what it is? Angle A. How do I find that? Perfect. Add up 90 and 31 and subtract from 180. Or there's even a shorter way. Since I know this is 90 degrees, 180 minus 90 is 90. I know these two have to be complements. So just 90 minus 31 is 59 degrees. Works out the same either way, though. You can do the 180 as well. So now I know that angle already. I need to find the sides. Well, let's say I'm going to try to find C here first. I'm going to use the angle I was given just in case I did something silly and I messed up that angle. It's always best to go back to given information. So I'm going to use the side that's given to me, the 14 inches, and the side I'm looking for is C. Well, what part of this right triangle is C? Leg or hypotenuse? Hypotenuse. And remember, that will not change no matter what. That is the hypotenuse of this triangle, period. But the other 2 sides are legs. And one of the legs is an opposite side leg, and one is an adjacent side leg. And it depends on which angle we're looking at. If we're looking at this angle, 14 is which one of those legs? Opposite. What trig function deals with hypotenuse and opposite? Secant does, but that doesn't help us. Or cosecant does. We want to use sine. Sine is equal to the opposite over the hypotenuse. So we put in what we know. Do we know the angle? Yeah, 31 degrees. Do we know the opposite side? Yeah, 14 inches. Do we know the hypotenuse? No, that's what we're looking for. That's side C. When we are looking for a side, this is the opposite side for this angle.
Well, I'm saying, like, say it's a circle, point A there would be the that circle up and down of the sign, right?
Yep,
And between B and C is
the cosine. Right?
so what would
But I'm using side B here, so this is the sine side. We're not using side A for anything right now. But A would involve the cosine. You're absolutely correct. Does that make you still look confused?
no, it's fine. That just seems like, I mean, to find side A and side B, don't you just do cosine and sine 31?
Yep.
So
No, not necessarily sine and cosine of 31, but if we knew the hypotenuse, we could do it that quickly. But we don't know the hypotenuse. So the first thing we got to do is we got to use this side to find the hypotenuse. So 1 times 14, we make it into a proportion and we cross multiply. 1 times 14 is 14 divided by sine of 31. $21.18 is side C. That's my hypotenuse. 21.18 inches is my unit. Now to find side A, I could use that hypotenuse, but I just calculated that, and there's two things. One, there's a chance that I may have made a mistake, and two, it's certain that I rounded it off. Because it didn't, the calculator didn't say 21.18, it showed something else that I rounded off to 21.18. So rather than using a rounded answer, I want to go back and use this number that was given, that 14 inches. And I'm going to use that to find A. So 14 is the opposite. According to angle B, A is the adjacent side. That would be tangent. Tangent of an angle is opposite over adjacent. Yes. I did 1 times 14, then divided by sine of 31. Yeah, so basically 14 divided by sine of 31. So then down here, I'm putting in my, what's that? Did I write it down wrong? Yes, I did. Wow. Yes, it was 27.18. Thank you. So then down here, the angle is 31. The opposite side is still the 14. The adjacent side is that side A that we're looking for. So again, I'm going to put this over 1. I'm going to cross multiply and divide. So 1 times 14 is 14 divided by the tangent of 31 degrees. Is 23.30. So that's 23.30 inches here. So I found the missing sides, and the angle I found by just subtraction. Now here it was one of the legs that I knew. So it looked like this. If I knew the hypotenuse, it looks a little different. So let's say I know that this is 42 inches. And let's say I'm given that this angle here is 41 degrees. I just label this A, B, C, little a, little b, little c. And again, I want to find the missing sides. Well, first I can find what really quickly again? Angle A is going to be 49 degrees because again, 180 minus 90 is 90, minus 41 is 49. So I have my angle really quickly. Let's find side A. Here's my angle. 42 is the hypotenuse, as I said. Side A is which one? Adjacent or opposite? adjacent according to angle B. So I make this the opposite according to angle B. So I am looking for the adjacent, and I have the hypotenuse. That would be the cosine. It deals with adjacent over hypotenuse. So I know my angle is 41 degrees. The adjacent side is side A. That's what I'm looking at. Over my hypotenuse of 42. I put this over 1. I'm going to cross multiply and divide. So here I've got the cosine of 41. Make sure I close those parentheses. Times 42. And I don't have to really divide by 1. I get 31.70 degrees. 31.70 inches, I should say, not degrees. 31.70 inches. To find side B. My handwriting is horrible today. Find side B. B's the opposite side, and I know the hypotenuse. Opposite and hypotenuse make up sine. Yes, so it's going to be the sine of 41 degrees equals that opposite side of B over the hypotenuse of 42. Put this over 1, cross multiply and divide. So yes, sine of 41, close parentheses, times 42, 27.55. Inches. Now, before we move on, let's make sure this makes sense. Remember, the smallest angle has to be opposite the smallest side. Where's the smallest angle here? Which one? B, 41. Its opposite side is little b. Is that the smallest side? Yes. Largest angle has to be opposite the largest side. Well, C is the largest angle. It's 90 degrees. The largest side is 42. Yes, it is. So that holds true. I mean, that doesn't mean that we did it correctly, but it means we didn't make a really stupid mistake. Make sense? What if you are given a right triangle and you're given two sides and no angles? Yeah, we're given that the one angle is 90 degrees, yes, we know that. But we're given the two sides and none of the other angles. We still have three pieces, just one angle and two sides now. Well, we can find the third side really quickly here by doing what? Right, a squared plus b squared equals c squared. Now, since we are looking for one of the legs, I'm going to shorten this up. Does that look familiar? All I did is I subtracted b squared from each side, then I square rooted it to get a. So a is equal to the square root of 31 squared minus 18 squared. It just allows me to punch in my calculator all at once, is all that does. 25.24 looks like. So I found the other side. Now I need to find an angle, and I'm going to go ahead and I'm going to focus on angle B here. No. You can't assume they're both 45. In fact, here you definitely can't, because these two are different lengths. Okay. For those angles to be both 45, those would have to be the same length. Now, if I'm looking at angle B here, I am going to use the two sides that were given to me. Like I said before, this one here, I calculated. There's a small chance it could be wrong. And it's definite that it's been rounded. So I'd rather go back to information that was given to me that I at least have reason to believe is exact. So this is the opposite side and the hypotenuse, which is sine. So I get the sine of the angle. Do I know the angle? No, it's angle B. That's what I'm looking for. Is equal to the opposite of 18 over the hypotenuse of 31. The last two examples, I was looking for a missing side. That's where I put this over 1 and I cross-multiplied and divided. I'm not looking for a missing side here, so I'm not going to put this over 1. I am looking for a missing angle. So I'm going to do an inverse trig function. This is a sine, so I'm going to do an inverse sine. So the sine and inverse sine cancel out, leaving with just b here. Inverse sine of 18 over 31. Remember, you do second sine 18 divided by 31, close the parentheses. It spits out 36.87 degrees. Did I do 30? Yes, I did. Thank you. Good catch. So we want to lose 35.50 degrees. So that's 35.50 degrees. I could do the same thing to find angle A, only it would be an inverse cosine. Or I could just do 180 minus 90 minus 35. That's 5450. But an inverse cosine would be the same thing. So at 54.50. Okay, any questions? In that packet, page 701, exercise 34-1, page 702, exercise 34-2, 705 and 708, exercise 34-3, and you guessed it, 34-4. Work on the odds.